Hi everyone, this is Shanmupriya from Cybersecurity Department working as an assistant professor from KSR College of Engineering, and today we are going to see about the queue data structure from an data structure and an algorithm. So what is an queue? So queue, it is nothing but it is a linear data structure that is used for your storing your and managing your data in a specific order in a memory. Okay, so it works on the principle of FIFO, that is in, first out data structure. So in the queue data structure has an two ends, that is in front end and then rear end. So in the front end, in the rear end you can add an element in the queue. So from the front end, you are deleting the element from the queue. So let me see about then a real-time example of an queue. That is, first one is an checkout line at a grocery store. That is an checkout line. That is who enter the billing section first will come out of the grocery store first. So this is an a real-time example. Let me see into the second example. The car at a stoplight. That is an that is an traffic signal. Next, the third example is an assembly line. So this is a conceptual view of a queue. So this is in the green color person is an so the green color person is at the front of the queue. Okay, and this blue color person is in last portion. It is in rear end. So the elements are will added at the rear end. Okay, this is an NQ of an queue. So this is a conceptual view of an queue. Now we are going to remove an element from the queue. So at the front end only the element is getting going to deleted, not at the rear end. Okay, the first element is an this person. So this person will be get removed from the queue at first. Next, the next element going to be deleted from the queue will be an this person. Next this, so it will be continued until the queue will be empty. So what are the operation we are going to perform on the queue? First is an a dequeue. That is, you are going to remove an element front from the front end of the queue. Okay. Next, what is an next operation is an enqueue. The what is an enqueue? You are going to add an element to the rear end of the queue. That is an last of the queue. So next operation is the first. It is going to examine the element at the front of the queue. Next is empty. Whether you are going to check the whether the queue is empty or not. Next operation is in size. It determines the total number of elements in the queue. Next is an toString. It returns a string representation of your queue. So this is an memory representation of the queue. So this is an front end, or we are called as an head also. So in the front end only the element is going to delete first. That is an you are going to perform an dequeue. At then rear end. So in a rear end only you are going to perform an enqueue operation. That is enqueue is nothing but you are going to add an element to the queue. So 2, 3, 4, 5, 6, 7, 8. These are the element in the queue. If you are going to delete you are going to perform an dequeue operation, the element 2 will be deleted first. That is from the front end of the queue. If you are going to add an element that is 9, so the element will be added after 8 in the rear end. So that is called as an enqueue operation in the queue. So what is the uses of queue in computing? It is used in a printer. So in a queue only you are going to, if there is a document of an 16 pages, your if you click on the print button, so it will get printed upon 1 to up to 16 pages continuously in the queue. So it will ordered in an queue. Next, keyboard input buffer. You are pressing the key right now, so that is an keyboard input buffer. GIU is an event. Click on a button, menu items. These are get you into an GUI event queue. So there is an two implementation of a queue. First is an linked list implementation, and then second one is an array implementation. So let me see then a linked list implementation of the queue first. In a linked list implementation, it is also when that is a queue is an a queue containing how many elements, that is an four elements in the queue. It is an linked list implementation. So there will be an data and then next field. In the next field there will be an address of an next one, address of the next node. Okay, so there is an four nodes will be in the queue first. So first one, it is pointing to the front is pointing to the first, and then this one is pointing to the last, that is a rear end. So if you are going to add an element next, so the element will be in the last position. If you are going to delete any element, that is an DQ of an queue, the yellow will be delete first from the queue. So this is an adding an element. If you are going to add an further element, that is a green element into the queue, it will be added at the rear end. So it will be placed at the rear end of the queue. So the total count will be now 5, that is incremented to 1. So if you are going to delete an element from the queue, the first element will be an yellow. So that will be going to remove first. So after deleting the yellow node, there will be an count will be an 4. Okay, so like after deleting the yellow, the front end pointer will be point to the red node. Okay, so this is an DQ operation of an linked list implementation of an queue. So second is an array implementation of an queue. So this is an array implementation from 0 to total number of count is an 4. So 0 to 4, the queue named as an AQ. This is an implementation, array implementation of the queue. So this is an example. So indexed value will be 0 to 7. The element, if you are going to the front end data will be 10 in the memory address of 5000. So rear end will be in 5020. It has an element of 50. Okay, if you are going to add another element, that is an 66, it will be added in the next to the 50, that is an rear end of the queue. If you are going to delete any element from the queue, the first element deleted will be 10 only. So this is a queue after removing n. So first element, if you remove an yellow element from the queue, so it will be starts from an red. So this is an queue ADT of a data structure and algorithm. Thank you.